right, hopefully we're wrapping things up here not too long. Again, you're answering all of these about this polynomial shown. If you are having a little bit hard time seeing that, again, I'll throw the Jamboard link in there. You can pull that up. This is on frame 2. All right, let's get some answers here. Let's have Zane give me the number of terms. I want Wahazi to give me the degree. I want standard form. I want Evelyn to give me that one. And leading coefficient, let's get Bree. All right. When you know it, you can throw it in the chat or unmute yourself. So Bree, you said your leading coefficient was 3. Absolutely. Awesome job. Wahazi, do you have the degree for this polynomial? What'd you get? Oh, that's standard form. You did the harder one. The degree is just the highest exponent. Oh. 2. There we go. You gave me standard form too. Evelyn in with the standard form as well. Awesome. We got 3x squared minus 4x plus 1. And then Zane, do you have the number of terms for me? Awesome. It is also 3. So this is the 2.0 skill that our other group is reviewing here. We just want, you guys seem to pretty much know your stuff when it comes to this, so we wanted to kick it up a notch here. The second skill that we're going to kind of want to reflect on today is this graphing. So Connor, can you unmute yourself and tell me how I would graph this line?
You put a dot on 1 on the y-axis.
Mm-hmm.
You then go up 2, and then left 1.
Oh, you're so close.
Right 1.
We go. Yeah, there we go. We go right 1. Awesome job, because it's a positive 2. And thank you, Connor. You can mute yourself again. So we could do that a couple more times if we wanted, just to make our line more exact, and we'd connect it. So today what we're doing is kind of a combination of both of these things. We are going to look at the equation and get some characteristics of that, but we're also going to tie it in with how the graph looks. So just like here, you guys can pick out from this equation that, oh, that's the y-intercept, and oh, this is the slope. We're going to do something similar today, but our equations for our graphs are going to look more like this, because that equation also has a graph. And we'll get more into that next unit. Today is kind of like we're stepping in just a little bit, okay, getting our feet wet. So here we go. We are on frame 3 if you are on the Jamboard. Gabrielle, can you read our I can statement?
I can interpret information based on a polynomial's characteristics.
Perfect. So like I said, we are looking at an equation, and from that equation, we're going to be able to tell a little bit more about what the graph of this equation would look like, okay? So here we go. Let's get off with some vocab first off. Show of hands, how many of you have heard or used those words maximum or minimum in math before? If you have, use the little raise hand button. You guys, Chardonnay, have you heard that before? No, maybe not. Couple of you? Awesome. So it looks like maybe some of us are familiar with this term. If you're not, we're just going to give it a very relaxed definition here. This is not the most mathematical definition. We're going to say that a maximum is a high point in the graph, and then a minimum is a low point in the graph. And again, this is not the most mathematical definition, but it is something that we can pick out once we see the graph itself. So I have two pictures here, and these both have some maximums and minimums. In this first picture, we have a maximum at kind of that middle point. That is a high point for us. So we could label that one a maximum. In this second graph, we have kind of two spots. I have this lower one and this higher one. So we actually have a maximum and a minimum here. Now, inevitably, I always get somebody that says, well, miss, what about like this spot and this spot? Those are low and high points. What about those? Okay. The other thing we want to keep in mind when we're talking about maximums and minimums is that these are also turning points. Okay. So even though this spot might be lower than this spot, we know that we can see that this one goes from decreasing to increasing. We kind of change direction, and this one doesn't. We kind of just keep going, and we don't know what happens. I kind of just cut off our graph here. This could keep going down, meaning that it wouldn't even be a low point here. All right, now on your assessment, though, I'm not going to give you this graph and ask you to point it out. I am literally going to give you these equations. I'm going to give you that, and I'm going to give you that, and I'm going to say how many maximums or minimums. And so our rule for that, I want everybody, make sure you get this rule down, star this, highlight it, whatever you need to. Our rule for this is that we do the degree minus 1 to find out how many maximums or minimums there are. So if I look back at this original equation, what's our degree in this original equation, Caitlin, in this first one? 2. Yeah, we have a degree of 2 here. So by our rule, we would do 2 minus 1, and that would tell me that we have 1 maximum or minimum, which if we look at our graph, absolutely, we had 1 maximum. So this number makes sense to us. Okay, let's look at the second equation. Chardonnay, what is my degree of that second equation? 3, absolutely. So if I take my degree of 3, and by my rule, I'd be doing 3 minus 1. That means I'm going to have 2 maximums or minimums, which again, we look at our graph, and hey, I had 2 of those. It doesn't tell us if one's a maximum or minimum. It just says how many there will be. All right, so if we can remember this rule, we will be golden. All right, so in class, can I get a thumbs up, thumbs down? And virtual people, can you give me a scale of 1 to 10? Tell me where you're at. I'll take 9-ish. Did you guys give me? Sorry, I totally zoned out. My bad. Okay, cool. All right, lots of 9s and 10s. That's what I love to see. So I'm going to move on to frame 5 because here's where we get to the fun stuff. This is what we call the leading coefficient test. So as we're thinking about what a graph looks like, we want to know if there are any like lumps and bumps, any maximums or minimums. But we also, a really good way to kind of see what the graph will look like is you look at the ends of the graph, and we call this end behavior. So sometimes like both the ends are going up, sometimes both the ends are going down, sometimes they're flip-flopped like this, and we can kind of get a picture of that. If I switch back to frame 4 for a moment, like we see that there's a lot of different things happening at the ends of our graphs. They're going in all sorts of different directions. Some are going up and some are going down. So there's actually a test, this leading coefficient test, to determine which way those the graph will be pointing on the left and the right side. And you have to look at 2 things when you're using this test. You have to look at the degree and the leading coefficient, both things that you guys are good at picking out, okay? So let's say we pick out our degree and it is even, meaning our degree is 2, 4, 6, 8, any of those even numbers. that tells me that both ends will point the same way. It doesn't tell me which way they will be pointing, but I know that they're either going to both be going up or both be going down. Give everybody a moment. If you're writing this down on a separate sheet of paper, you want to get this for sure. All right, so once we pick out the degree, then I said our second piece of information we had to pay attention to was the leading coefficient. Okay, and your leading coefficient, I don't care if that is even or odd. What I care about is if it's positive or negative. So if your leading coefficient is positive, that means that the left and the right will both be pointing up. So your graph, we know that they're both pointing in the same direction. They're both be going up. It would look something like this, a smile. And kind of the way that I like to remember this is that, oh, it's positive. And when you're positive, you're smiling. Yay. All right, now if it's negative, then I'm sure you guys can guess which way our sides will be pointing. Instead of pointing up, they will now be pointing down. And instead of like a smile, our picture is going to look a little bit more like a frown. And again, I go back to being cheesy. We're negative, we're sad, we're going to be frowning. All right, so that's half of our leading coefficient test because all we've looked at are the cases if we have an even degree. However, obviously, that's not the only case. If you can have even degrees, you can also have odd degrees. So I'll give everybody about 10 more seconds, then I'm going to go on to that next frame in our Jamboard here. Are you guys still with me? Yeah? All right, so if we have odd degrees, so meaning that your degree is 1, 3, 5, 7, 9, any of that stuff, this means that the ends will go in different directions. So before, when we had even degrees, they were either both pointing up or both pointing down. If they're odd, they're flip-flopped, and I like to call this the squiggle function. That is not its proper term at all, but we're going to have kind of this weird squiggly shape going on. Again, if you're on the Jamboard, we're on frame 6. Okay, so once we determine the if the degree is even or odd, then again, we're looking at that leading coefficient. So if it's positive, the left side will be pointing down and the right side will be pointing up. Okay, and there could be lumps and bumps, maximums and minimums in the middle, but really all we care about are those ends. So I could have something that looks a little bit like this. I could have a bunch of bumps going on. But what I care about with this leading coefficient test is figuring out how my ends look. And because it was odd, they're pointing in different directions. And then because it's positive, we start with the left going down and the right going up. And the way that I like to think about this is that if it's positive, if we think back to when we first started graphing, a positive slope would be increasing from left to right, which is kind of like what this looks like now. We have our increasing line from left to right. So the negative, it's the exact opposite. The left will be pointing up and the right will be pointing down. So your graph is going to look like this. Again, this time I have less bumps in the middle. We don't know exactly. I won't know this until I figure out the degree. Then we do our degree -1 trick. But we're really looking at these ends here. So here we have a negative. And again, the way I like to think about this kind of looks like a decreasing line from left to right. All right, I'm going to pause for questions because that was a lot that I just threw at you. If you have a question, throw it in the chat. Don't be afraid. And then as you're processing that, I'll get started on an example problem for us. If you have questions, throw them in the chat. I'm here to help. Do you guys have any questions so far? I know I'm kind of stationary today. Normally I'm walking around a little bit more. All right, I'm going to move on to frame 7. So on frame 7, this is not on that note sheet. This is just a random thing that I've added. I just want everybody to stay with me. So Evelyn, can you give me the degree, please? And Wahazi, can you give me the leading coefficient? Two, or is our leading coefficient? Absolutely. And then Evelyn, yes, our degree is 5. Good job, you guys. So what we need to do is decide if our degree is even or odd. So everybody, degree of 5, do we have an even or an odd number? Yeah, let's see if our virtual people agree. Hello? Thank you. We have an odd number. So I'm just going to make a note to myself that this is odd. I'll need that in a moment. And then for our leading coefficient, hopefully you guys all know that 2 is positive. So, yep. So we have a positive and an odd. So if we have an odd, let's go back to our rules. Will our ends be pointing in the same direction or different directions? Different directions. Yeah, so this is going to be different. I'm just going to make a little note to myself. And then positive, that's going to mean that it's going to look like it's increasing. So from the left to right, we're going to start down and then go up. So here, I don't have an exact of what my graph would look like. I can also say that there would be, if I want to, our degree minus 1 would be 5 minus 1. So I would have approximately 4 mins or maxes. So here, I would start down and end up. And if we look, I have 1, 2, 3, 4 maximums and minimums. All right, so scale of 1 to 10, where are we at, you guys? You feel good? Awesome. Love it. Okay, well, you know me. Of course, I have to up the ante. I got to give some notation here. And the notation is usually where I lose everybody because it has an infinity in it. Don't let the infinity scare you. We can do this. All right, so if you have those notes printed, you are flipping to the back. Okay. Now I want to think about the coordinate plane really quickly. So on my coordinate plane, if I just draw a little coordinate plane here, if you're on the Jamboard, I'm on frame 9. I have my x-axis and I have my y-axis. Okay, and those can tell me if I'm moving left or right or up or down, right? We're all okay with that. Well, we're going to start describing those with infinities. So let's say I'm just talking about my x-axis. I'll do my x-axis in green. If I'm going to the right, these are all going to be positive numbers on my x-axis. So if I keep moving to the right, I'm going to be moving closer and closer to positive infinity. Again, stop me if you're confused. I'm going to positive, so I'm going to have positive infinity. On the other side, though, if I move to the left, I'm getting more negative and more negative and more negative the farther I go. So on the left, this is actually going to be negative infinity. Yes, you can have a negative infinity. It does exist. Okay, well, we do the same thing with our y-axis. So if I keep moving up, my numbers are getting larger and larger and larger the farther I move up. So I am getting closer to a positive infinity if I go this way. And then if I keep moving down, my numbers are getting smaller and smaller. They're getting more negative, more negative. I'm moving closer to a negative infinity. Okay, and this is where our notation comes from. So over here, we have this x with an arrow and then an infinity sign. The way we say this is as x approaches infinity. okay? And what that basically means, that means on our x-axis, we are going to infinity. So that basically is telling us we're going to the right. All of that crazy notation just to say right. So if I wanted to say to the left, instead of x going to positive infinity, I'm going to go to negative infinity. And again, it's my x-axis because x determines if you go left or right. And we would say x approaches negative infinity. Okay. So then if we think about our y values, if y is approaching positive infinity, are we moving up or down, you guys? If y is approaching positive infinity, am I moving up or down? Let's see. Yeah, thank you. We got it in class and virtually. We are moving up. And we would say y approaches infinity. On the other side, if we are wanting to move down, we would say y is approaching negative infinity. And if you're having a hard time writing infinity signs, sometimes I do as well, as you can tell, turn your paper, write an 8, turn it back. And this time we would say y approaches negative infinity. All right, so here is the culmination of everything we've learned today. This is kind of like what a problem on your FA will look like. So here is my polynomial. I want to pick out those 3 things. Well, let's start with 2. I want to pick out the degree and the leading coefficient. So Connor, can you give me the degree? And Caitlin, can you give me the leading coefficient? Connor, yep, our degree is 3. And our leading coefficient is -4. So our degree, 3 is an odd number. I'm going to make a note of that. And our leading coefficient, -4, that's obviously a negative number. Going to make a note of that. So if it's odd, if I go back to my leading coefficient test, this means that we are going in opposite directions. And then if it's negative, this means we're going up, then down. And if you don't have these memorized, that's okay. I have them memorized because I've taught math for a billion years. I expect you guys to have to reflect back to your notes for this. So the way that we would write this, I have is x is approaching negative infinity. That's basically saying what's happening as we go to the left. So if I go back to these characteristics, if I draw my little picture, we're going to have opposite directions. One will on the left will be going up, on the right will be going down. So as I approach the left, am I going up or down, people? On the left side, am I going up or down on my graph? Up. So the way I say that, go back to my chart, I say y is approaching infinity. We were going up. All right, then let's look. This is saying, I'll even write it in little notes for you guys. This is left. This is right. So now I want to know what's happening on the right because that's when x is approaching infinity. And if we look back at my chart, we can see I'm going down. How will I write going down? Y is approaching. Yeah, we got it. Let's see if our virtual people get it. If I want to say going down, Y is approaching. Help me out. Help me out. Y is approaching what? Oh my goodness. Chardonnay already told me. Brianna, do you know? If I want to say that Y on the right, we're going down, I'm going to say Y is, oh, goodness gracious. I'm going to say Y is approaching negative infinity. All right. Good. There we go. Thank you, Evelyn. All right. I'm going to stop my recording. And actually, we are out of time and we have reached the end of our notes. So it's perfect timing, just barely